Now let us see some more designs on inverters. First thing is we will discuss about pseudo NMOS inverter, which is again the ratioed logic which we have discussed before. Pseudo NMOS inverter will be looking like this, where you have one NMOS and one PMOS, and you know that the PMOS is grounded, so the PMOS is always on, right? PMOS is always on, and that is an NMOS which is compulsory for all the inverters. I told you for an inverter the NMOS is compulsory, and in the load side you can have either a PMOS or a PMOS with grounded, which makes it pseudo NMOS inverter, or even a resistor. So this is the typical design of the pseudo NMOS inverter, guys. And when you look at the operation of this inverter, when you are making the input as 1 means, that is the input as 1, NMOS is grounded, right? So it is always on. So there is a virtual short here, that is always on. And since you are made the input as 1, so the PMOS is also on. I mean the NMOS is also on. PMOS is always on because it is grounded, okay, and the NMOS is on since you have made V in as 1. The NMOS is on, so both are shorted. So if the output will be pulled down first. The output will be pulled down, right, because NMOS is more dominating compared to PMOS, so the output will be pulled down. When you apply 1, so you'll be getting 0. So that's how inversion happens. That's how inversion happens. If you are making V in as 0 means, in this circuit, if you can make V in as 0, NMOS is grounded, so it is 0, it is always on. If you are applying this as 0 means NMOS is off. Sorry, this is PMOS. PMOS is always grounded, so it is always on. So NMOS is off when you apply 0 to it. So there is no connection here. This is off. So output will be immediately pulled up to 5 volt, which means output is logic 1 when you apply 0. That's how inversion happens. Simple operation of a pseudo NMOS inverter will look like this. Thanks a lot. We will discuss about resistive load inverter in the next video. Thanks a lot.